previous video of this series, we created a switch panel from a solid maple board and used it to assemble the switchboard. In this video, we'll be working on another component of the case, the rear panel. The rear panel will house a medium-sized fan and I/O ports. The dimensions are annotated on the drawing, which are 10.5 inches wide by 4 1/8 inches tall. I'll be using these sub-panels designed for DB25 ports. Each one has 2 ports for a total of 4 ports. This will allow us to connect a variety of different input and output devices to the Mark-8. We will also mount a fan to the middle of the rear panel to facilitate air circulation through the computer. Although the computer itself hasn't been a significant source of heat, the power supply tends to get quite warm. At the lower section of the panel, we will include openings for a fuse holder and the power cord, both measuring 1/2 inch in diameter. I would like to use this drawing as a template to assist with cutting and trimming the maple board, but unfortunately it's not drawn to scale as I could not fit the entire panel within the boundaries. Therefore, I drew a scaled copy of the rear panel, which will be used as a template for making the cuts. The board we will use for the rear panel is a 1/4 inch thick piece of maple. We will mark it and then cut it to size. Once the board is cut, we can place the template over it and use some tape to hold it in place while we work on it. Using clamps to secure boards is highly recommended when drilling and routing. Start by drilling a pilot hole precisely in the center of the fan diagram. For the fan, we'll employ a 3-inch hole saw to carve out the necessary opening. Following that, pilot holes should be drilled for both the fuse holder and the power cord. Subsequently, a 1/2 inch drill bit can be used to complete these holes. Gentle drilling is advisable to avoid shredding the wood. After completing the holes for the fuse holder and power cord, we'll proceed to the I/O ports. For creating the openings, a 1/8 inch router bit will be used. To facilitate this, start by drilling pilot holes at each corner of the interior section of the I/O ports. This is the section that will be cut out. The router bit should fit smoothly into the pilot hole we just drilled. Once inserted, fine-tune the guide to align flush with the board's side, ensuring our cuts remain straight. Verify that the router bit extends sufficiently to complete a full cut. Should the paper template interfere, apply extra tape to hold it in place. Having completed all the cuts, we can now clear out the scraps from the board. So far so good. The next step is optional, but I believe it will enhance the appearance if we route out the outer edges of the I/O ports. This will allow the sub-panel to sit flush with the board. Adjust the router bit's height by aligning the sub-panel against the router base and moving the bit up or down as needed. As before, use the guide for straight cuts. For now, we'll only route out the outer perimeter. With the perimeter cut out, we can proceed to remove the template from the board. The next step is to use a larger router bit, in this case I'm using a 3/4 inch bit, to clean out the rest of the outer perimeter. Ensure the router bit height is set correctly to avoid cutting too deeply, as happened in my case. Fortunately, the overcut will be concealed by the sub-panel. In this step, we are not using a guide to make the cuts as we have some leeway. so we can do them manually. However, one could opt to use a guide if preferred. After completing this step, a chisel can be used to smooth out any residual unevenness. The board is shaping up nicely so far. We have one more step remaining in this process, and that is drilling holes for the bolts. Position the sub-panels in their designated spots, and then drill pilot holes through the bolt holes in the sub-panels. As we'll be using M3 bolts to secure them, I found that a 9/64-inch drill bit is sufficiently large for this task. Next, align the fan's interior circumference with the hole in our rear panel, ensuring the top of the panel is parallel to the top of the rear panel. While holding it steady with one hand, use the other hand to drill pilot holes. Alternatively, create a paper template of the fan, position the template over the rear panel, and then drill the holes using the template. With the same 9/64-inch drill bit, proceed to drill the final holes. Back at the workbench, I mounted the fan and sub-panels to the rear panel using M3 bolts and nuts. The rear panel is not fully complete yet, as we still need to sand it and stain it with the rest of the case, but this gives us a good idea of what it will look like when completed. I hope you've enjoyed this video. Please don't forget to like and subscribe, and I'll see you in the next one.